I can see you. A very good evening to you. Okay, let me quickly um, do a little bit of settings. Okay, good. Yeah. So welcome to the live class. In today's class, we shall be looking quickly at rounding up in two subtopics our discussion on introductory statistics, particularly on an introduction to correlation and regression. So in today's class, I would love all of you to call on your colleagues to join the live class, smash a like on the video, do well to give us your good comments, and most importantly, if you haven't subscribed, please subscribe to the channel. So welcome to this class. Please call on your friends because we'll be doing something very serious in today's class. Yes, Uforo, welcome. I can see you. Good evening. Welcome. Please signal your friends. Sorry for the little delay. I had to take care of certain things. So sorry for the delay. Welcome to the class. In today's class, what shall we be doing? We shall be looking at something very important. We shall continue particularly from where we stopped in the last class. Let me give you a quick reminder of where we stopped in yesterday's live class. So in yesterday's live class, we were able to establish before ending the class that if Uka, welcome, good evening. So we were able to establish in yesterday's live class that if there are two variables x and y related, and we know that they are related, it is very possible to establish a model involving these two variables. So we established that y, welcome, Abalola Ademola, welcome, I can see you, welcome. So in yesterday's class, we were able to establish that you can regress y on x. Okay, let me write it this way. So, y can be regressed on x. Okay, so if there are two variables, y and x, let's assume particularly that you are carrying out a research. Let's assume that you are carrying out a research to study the relationship between one factor and another factor in society. Let's assume in your research you are trying to study the impact. You want to study the impact of a variable y, let's say waste, improper waste disposal. Okay, let me do it this way. So let's assume, I want us to look at it practically. Let's assume that you want to observe the relationship. You are carrying out a research that involves observing the relationship existing between improper waste disposal, okay, and flooding. Okay, so let's assume that you are carrying out a research observing the relationship between improper waste disposal and flooding. Now, improper waste disposal can be taken as a variable x, and flooding can be taken as a variable y. Okay? Now, if in particular this is the kind of research you are looking at, or this happens to be one of the hypotheses in your research, in yesterday's class or yesterday's episode on correlation and regression, we were able to establish something. Now, if you don't remember, you can look at that, you can watch that video all over again. Yeah, blessing, you're welcome. I can see you. Welcome. Now, if you did not follow up yesterday's class, or you've forgotten what we've done in yesterday's class, quickly go back to the video and watch all over again when this class ends. So what did we do in yesterday's class? If you assume that you are writing a research on improper waste disposal and flooding, or this is somehow one of the hypotheses stated in your research, that there is no significant relationship between improper waste disposal and flooding, and you want to investigate if how strong the relationship is between X and Y. Yesterday we were able to establish that one can model the relationship between X and Y. Okay, now modeling the relationship between X and Y is the aspect we call regression. So regression takes care of modeling, and correlation takes care of measuring the strength of a relationship. We have said this before now. Now, the thing is this: if you assume Y to be your dependent variable, then it is possible to do this. It is possible to regress Y on X. Regressing Y on X. If you regress Y on X, it means you are assuming Y to be the dependent variable, and you are assuming X to be your independent variable. And I want you to take note of this. It is very important. So, if there are two variables involved in a bivariate data, one can actually regress one variable on the other one. Now, if out of the two variables, say X and Y, you choose Y to regress on X, it means automatically that you have chosen Y as your dependent variable and X as your independent variable. Now the question is, what will the model in this case look like when you regress Y on X? That is taking Y as your dependent variable and X as your independent variable. What will Y be? Y will be the dependent the dependent variable, and X will be the independent variable. And what will the relationship or the model be? The model will look like this. So if you are regressing Y on X, you end up having a model that looks like this: AX plus B. Okay? In this case, this model or equation is called a regression equation or a regression model. Okay? So when you regress Y on X for a bivariate data, you would have a model in this form that looks like the gradient intercept form of a line. Okay, in this case we say that this is a regression model, and I'm going to tell you what type of regression model that is, but just hold on to what I'm saying and try to follow the story. Now the story begins with saying that if there are two variables involved in your bivariate data, of course, then you can regress one variable on the other or regress the other on the other variable. Okay, so if there are two variables Y and X, you can regress Y on X. What does regressing Y on X mean? It means taking Y as your dependent variable and taking X as your independent variable. Now, the same way you can regress Y on X, you can also regress X on Y. And in that case, when you regress X on Y, it means that you are trying to make X your dependent variable and Y your independent variable. Okay? So when you regress X on Y, it means that X has become your dependent variable and Y has become your independent variable. So in that case, your regression model will no longer look like this. Rather, it will now look like this. It will now be X equals A prime Y plus B prime. Now I'm using A prime in this case and B prime because the constants, when you regress Y on X, these constants called parameters of the model will not be the same as the parameters of the model when you regress X on Y. So I'm using A prime to differentiate from A, the parameter A, and B prime to differentiate from the parameter B. So the story I want to begin with in this class is that in a bivariate data, two variables can be regressed one on another. If you regress one on the other one, the first one becomes the dependent variable and the other one is the independent variable. If you regress the other on the first, then the other becomes the dependent variable and the first becomes the independent variable. Now, and their regression models will look like this. So this equation with which you model the relationship between Y and X or X and Y is called a regression model. Okay, so if somebody should ask you, can you give me a regression model involving two variables X and Y, this is the kind of model they want. This is the kind of model. A model is an equation relating the two variables. Okay, this is the kind of equation you will get where A, the coefficient of X, acts as the gradient of a straight line, the regression line, and B is the y-intercept. And if you are regressing X on Y, A prime is being the coefficient of Y is the gradient of the straight line, in this case the regression line, and b prime is the x-intercept, because you are now taking your x variable to be your dependent variable. Now, what do we want to do in today's class? I want to show you how to obtain the parameters of this model A and B. A question given to you would require you, if a question is given to you, let's say a data is given to you, oftentimes you will be requested, when a question is given to you involving correlation and regression, the question would always come with wanting you to obtain a regression model for the bivariate data. So the question is, how do we get the value of A and how do we get the value of B? Because without getting the value of A and the value of B, you cannot write out the regression model. So how do we get the values of A and B? So let's do it together. Now, if you want to get the values of A and B, we write the values of A to start with. A is given as the summation. Let's assume that we want to regress A on X, in which case we have AX plus B. Now, regressing Y, we want to regress Y on X rather, in which case we have Y equals AX plus B. Now, regressing Y on X gives this kind of regression model, but this model has parameters that are unknown. So the question is, how do we obtain the values of A and B? To do that, we will start with writing summation x minus x bar in bracket y minus y bar all over summation x minus x bar all squared. Okay? Now this goes from 1 to n and from 1 to n. Now you would remember in my class with you guys that I have talked about this symbol summation. It is used as a shorthand notation. Gideon, welcome, good evening. This summation symbol is used to represent that a set of items are being added starting from the first item to the last item. Okay, so this is what we are going to do. To get A, we would write in this manner, and to get B, we would say B would be equal to y bar, the mean of y, minus A times the mean of x, to get your B. Now, this is a particular equation that you could use to obtain your A in straightforward manner, or you could use to obtain your B in straightforward manner. But you would notice that this appears to be more demanding. So there is a simplified form of writing A and a simplified form that translates into writing B eventually. So what would you do? Let's now do it together. Please, I would want you guys to pay attention to what is being done. Okay? I'll try my best to explain and break everything down to the best of my ability. And I would encourage questions from you, comments from you. Should you not understand anything, please don't just be silent. Make your questions known and I would explain. Now, let's start with this. I'm going to call this equation 1 and I'm going to call this equation 2. Okay? So, again, we are starting with a case of regressing y on x. And regressing y on x means, in this case, we are assuming y to be the dependent variable and x to be the independent variable. And a regression model of y on x is a model of this form, in which b is a constant and A is also a constant, and both of them are called parameters of the model. Okay, now let us look for a simplified form of A. So I'm going to write here simplified form of A. Okay, so how do we obtain a simplified form of A? I'm going to bring what A is down. I'm going to bring equation 1 down. Okay, and I will write this: I equals 1 to n x minus x bar times y minus y bar all over summation from I equals 1 to n x minus x bar all squared. Now take note, where is the I coming from? This is I, and this is I. It is iterating. Now, x bar, you will notice that x bar has no I, y bar has no I. X bar having no I means it is a constant, y bar having no I means it is a constant. Both of them are means, okay? X bar is a mean and y bar is a mean. X bar is a mean also. So what you would start with doing is to expand, okay? Now, To expand, I'm going to do this. I'm going to start with leaving my summation from I equals 1 to n, and then expanding this, and this. Now, expanding this and this means xi times yi will give me xi yi. If I use xi to multiply y bar, I'm going to have xi times y bar will give me xi times y bar, and y bar minus y bar, so you have minus xi y bar. Okay, now you will come over to the next one. Minus x bar times yi will give you minus x bar yi, and minus x bar times y bar will give you plus x bar y bar. Okay, and that is the expansion for the numerator. You will now come over to the denominator and also expand. Now, if you expand the denominator, this will be summation from I equals 1 to n, and you will now expand this. Now, expanding this is done in very simple terms. If you expand xi minus x bar all squared, it means you have to multiply xi minus x bar times its own self, and that means xi will multiply itself. You end up having xi squared. Xi would multiply x bar twice, and that will give you minus 2xi x bar. Then minus x bar will multiply itself to give you plus x bar all squared. Okay, so that is what you are going to have. Now, can we simplify further? The question, the answer is yes. Now, I would want everybody to remain steady and watch this video keenly, because what we are doing is very important, and we are going to arrive at a result. For you to follow what we are doing, you must pay attention and you must be steady while watching this particular video. Okay, it is very, very important. Now, at this stage of the expansion, the next thing we are going to do is this. Summation of this, I'm going to come into the bracket. I wouldn't tamper. I would take this summation, the summation of the first one. Summation opens this bracket taking xiyi. Summation will take on the next item. Now, one thing about summation as an operator is that whenever you use summation on a product of a constant and a variable, it will push out the constant and attack the variable. Okay, it will go with the variable, bringing out the constant. So the mean y bar is a constant, but xi is a variable. So this one is a constant, this is a variable. So when you take summation of the two of them in product, what you are going to have will be minus y bar coming out, and summation from I equals 1 to n going with xi. Okay? Now, when you take summation of the third term, if you take summation of the third term, you would end up having minus x bar being the constant, summation yi from I equals 1 to n. Then if you come to the last one, you end up having summation plus summation x bar y bar from I equals 1 to n. That will be the result for the numerator. Now, at the denominator, if you come over to the denominator using summation again to open up the bracket, you would have summation from I equals 1 to n of xi squared. Minus 2 will come out because it is a constant. X bar will come out because it is a constant, and summation will go with the variable xi. Again, here you would have summation x bar all squared from 1 to n. Now, I'm going to hold this result closely. I'm going to bring this result here because I want to continue on another sheet. Now, from this result will come the next result, A. Now, this is not a constant, so it comes back with summation from I equals 1 to n. I will have xi, yi. I'm bringing it out of the bracket. Whether or not it's in the bracket in this case makes no meaning. So this is y bar. Now, let me show you something quickly at this point. I'm going to make a remark, a very quick remark. Let me show you something using this colored pen. Now, I'm going to do something here to summation xi. Note, recall that the mean x bar, the mean of several values of a random variable x, will give you summation. If I ask to find the mean of a set of values, I can write the mean as x bar equals summation xi from I equals 1 to n all over n. Now, if I make this numerator the subject of formula, if I make this numerator the subject of formula here, if I choose to make the numerator the subject of formula, it means this n would multiply x bar. And what are we going to have? This will give us n times x bar is equal to summation from I equals 1 to n xi. And that means in place of this x bar here, in place of summation from I equals 1 to n xi, instead of me putting that summation, I can simply put nx bar. So I'm going to bring in nx bar here, and that will be times nx bar from this. Okay? Now, if you come over to the next one, you have x bar minus summation from I equals 1 to n of all yi's. Now, if you bring that one also, you will notice that y bar can be expressed also as summation from I equals 1 to n of all yi's all over n. And that will give you ny bar equals summation from I equals 1 to n yi. Now, again, it means that I can replace this. I can replace this summation with ny bar. So wherever I find summation yi, I'm going to replace it with ny bar. So I'm going to quickly bring that here and then put in place of this, I'm going to put times ny bar. Then finally, for this result, x bar is a constant, y bar is a constant. If you add a constant a good number of times, if you add a constant 3 times, it will give you 3 times, the result will be 3 times that constant. So if you add x bar, y bar, a product of 2 constants n times, you are going to get n times the product of the 2 constants. That is, you are going to end up having here, you are going to have n x bar, y bar. Why is that so? It is because x bar and y bar are constants. So when you add a constant a number of times, the result will be the number of times you add that constant times the constant. So let me give you an example quickly. Let's assume that I'm adding 3 times. What is 3 added to itself 3 times? It will give you 9. That 9 is the same thing as 3 times 3. If you add 5, for instance, if you add 5 to itself 4 times, the result will give you 20. This 20 is the same thing as 4 times 5. So if you add x bar, y bar to x bar, y bar to x bar, y bar 3 times, the result will give you 3 x bar, y bar. But in this case, you will notice that we are adding this n times. So the result will give us n times x bar, y bar. Okay? Now, having said that, we'll come to the denominator. Coming over to the denominator, let's see what is there in the denominator. We have summation from I equals 1 to n of xi squared, and that will come because it still remains a variable. I'm going to leave that result like this. Okay? But to this other one, the same thing we did earlier on. This is summation xi. Remember, we said that it will be replaced with nx bar. Okay? So I'm going to bring nx bar to replace this, and this will be nx bar times nx bar. Then I will come over to the last one, this one. When you sum x bar squared, x bar is a constant, so when you square x bar, it will still give you a constant. And when you sum that constant n times, it will give you n times the constant. So this result will be nx bar squared. Okay? Now that we have gotten this, we will now go further to simplifying our result. Simplifying the result, let's start with the numerator. You are going to have summation from I equals 1 to n, xi, yi. Then, when you simplify this and rearrange it, n times y bar times x bar can be arranged as nx bar y bar. When you rearrange this, you are going to have minus nx bar y bar also. And the last one will give you plus nx bar y bar. Now, you will notice immediately that this plus this minus this gives 0. Okay? And it goes off. All over, the next result is summation I equals 1 to n xi squared minus 2 nx bar squared. When x bar times x bar multiplies, it gives you x bar squared. And when it multiplies 2 and n, you have minus 2nx bar squared. Okay, then this will be brought down as nx bar squared. Now if you simplify further, you will end up having that your result becomes summation from I equals 1 to n xi y bar yi minus nx bar y bar all over what you now have here, summation xi squared from I equals 1 to n minus 2 oranges plus 1 orange will give you minus 1 orange. So these two are like terms. This is just like saying minus 2a plus a. Minus 2a plus a will give you minus a. So you end up having minus x bar squared as your result. Okay? Now, if you put in what x bar is, let's now put in what x bar is. I'm going to bring it here. This is summation from I equals 1 to n xi yi minus n times what x bar is. X bar is summation from I equals 1 to n all over n of xi. What is y bar? It is summation from I equals 1 to n of yi all over n. One of these n will cancel one of these n, leaving us with just one n at the numerator. So if you come to the denominator and do the same thing, summation from I equals 1 to n xi squared minus n in bracket, what is x bar? Summation from I equals 1 to n xi all over n all squared. Again, one of these n will cancel one, the n here will cancel one of the n's, and you'll be left with just one n. And this result will translate to the next thing. Now, I've told you, tell your colleagues to come around, kindly tell them to come around, please. This class is very important because of what you are seeing at the moment. If you don't understand, at the end of this video, take pains and be patient to watch this video all over again with a paper by your side, following what I'm doing step by step. It is simple. It is very simple. Only if you observe what I'm doing step by step. And if you don't understand, please do not stay silent. Ask any question, I would explain, okay? Ask a question, I would explain. And please endeavor to give a like to the video while it is going on and even after we are done. Now, let's continue. At this point in time, I will bring my result here. A, summation from I equals 1 to n, xi, yi, minus, now that I'm left with just one n at the denominator, I'm going to have I equals 1 to n, xi in one bracket, times summation I equals 1 to n, yi in the other bracket, all over n, and all over summation from I equals 1 to n of xi squared minus, this n cancels one of the n, and you'll be left with summation xi from I equals 1 to n all squared all over n. Now, you can actually simplify this to get the final result. The final result becomes A equals summation from I equals 1 to n xi yi. What is the LCM of, this is the same thing as writing over 1, this is the same thing as writing over 1. So what is the LCM of 1 and n? It is n. Okay, I'm going to bring this, I'm going to erase this and bring my equal to here, okay, because I'm going to have this. Now, the LCM of 1 and n is n. I'll bring that n here. Now, 1 into n is n. N times the numerator is what you are going to have this. That is, you have this, n times this. Now, n into n is 1. 1 times this numerator here will give you minus the numerator, n from I equals 1 to n of xi times summation from I equals 1 to n of yi. Then when you come to the denominator and repeat the same thing, the LCM of 1 and n is n. I'm going to bring that LCM here. Now 1 into n is n. N times the numerator will give you this. And n into n is 1. 1 times this numerator will give you this. From I equals 1 to n xi all squared. Now, if I give you a thing like this, a over b divided by C over B. The result will give us A over C. Now, you will notice that what you have here appears to be your A. What you have here appears to be your C. So if you do this division, you would end up getting a result. This as your final result. You will get this to be your final result. N summation I equals 1 to N xi yi, okay, minus summation from I equals 1 to N xi summation from I equals 1 to N yi all over summation from I equals 1 to N times N xi squared minus summation from I equals 1 to N xi all squared. So this will be the final result for A. This will be the simplified expression for A. Okay? Now I'm going to show you how to use this result. Remember, B, if you can get the result for A, then your B can be expressed as y bar. Your B can be expressed as what we have stated earlier. That is y bar minus ax bar equation 2. So I'm going to write this as this. So that is what you are going to have. That's the final result we really need. Now please, I would demand that you ask questions before we proceed. Kindly ask your questions if you have any question to ask. What I'm showing you now may be coming to you very fast. That does not mean it is difficult. Because it is coming to you fast and for the first time, probably your first time of seeing this routine, it does not mean it is difficult. Now let me quickly explain, let me quickly go through what we've done so far. So let's start from here. Okay? Now, in today's class, for those of you just joining in, our task was to do this. We ended our class with stating this. Yes, Prosper, welcome. We started our class with this. Now, this is where we started our class. We said that it is possible to regress a variable y on x, and it is also possible to regress a variable x on y. Now, if you regress a variable y on x out of two variables in the bivariate data, we are saying that the one you regress on the other is the dependent variable, and the other one is the independent variable. So, if I regress y, thank you very much, Prosper. If I regress y on x, what it means is that nobody needs to tell you that regressing y on x means that your variable y is your dependent variable, and x, the other variable, is your independent variable. And the same way it is possible to regress y on x, implying that y is your dependent variable and x is your independent variable, you can also regress x on y. And when you regress x on y, it means that x is now your dependent variable and y is assumed to be your independent variable. Okay? So, what then should we now do? Having said that, the next thing I did in this class so far was to now show you that this A and B, A is what we know as the slope of a line, and in this case a regression line. This A here is the slope or the gradient of the straight line, and this B is the y-intercept. But in regression we call A and B parameters, where A here is the coefficient of x and the parameter of the model, and B is also another parameter of the model, which is the grand mean. Now, what I said was that you can use this formula, equation 1, to obtain A, because when you are given a question in regression, they would usually want you to model the relationship existing between y and x. And to model the relationship between y and x means to write an equation of this form, where A will not be a constant, unknown constant. It will be a value. So this could be a value, say 5, 0.3, 0.8, 3.9, and B must be a value also. And the question I started with asking in this video was, how would you obtain A and B? Because without obtaining A and B, it means you have not gotten a model. Yes. What is the difference between dependent variable and independent variable? Sorry, I came late. Okay, Prosper, welcome to the class. Let me answer that question. Your dependent variable is that variable out of the two that needs the other variable to determine its value. So let me give you a clear illustration. For example, in a home, there is a father and there are children. Now, who provides for the children? The one who provides for the children and has to provide for himself, needing no child of his to provide for himself, is the independent variable. The father assumes the role of the independent variable because he does not need the children to provide for him. He does not depend on his children for sustenance. But his children, to go to school, they need their father. They need money from their father. For their health issues, they need money from their father. For snacks, they need money from their father. Everything they need, they depend on their father for it. So for that reason, the variable that depends on the other variable for its value is called the dependent variable. And the one that does not need the other for its own value is called the independent variable. So I'm saying in correlation, we usually would have to pick which variable is the dependent and the other one will become the independent for a bivariate data. So y in this case is being regressed on x, making y the dependent variable and x the independent variable. So I said you can model the relationship between y and x. Modeling the relationship between y and x can be done in two ways. One can tell you to model the relationship between y and x, and if somebody tells you to model the relationship between y and x, please ask the person, which one should I regress on the other? Should I regress y on x or regress x on y? Because the modeling can go both ways. If you are regressing y on x, it means that y has been chosen to be the dependent variable, the variable that needs x for its own value. And if you are regressing x on y, it means that x has been chosen to be the dependent variable, and automatically y will be the independent variable. Now, I am telling you, any regression question would always demand that you get what is called a regression model. This is a regression model involving the regression of y on x. So in this model here, y is the dependent variable and x is the independent variable, because for us to determine a value of y, we need to know a value of x and the values of these constants a and b. So y is the dependent variable and x is the independent variable. Now the question is, if you are given a question and the question demands that you model the relationship between y and x such that y is the dependent variable and x is the independent variable, what would you do? What you should do will be to obtain the values of a and b. And the next question is, how would you obtain the values of a and b? After my explanation now, I'm going to solve a simple problem showing you how to do this. Don't mind all the complexities of what I have done. I would explain it. I will give a quick explanation to what I have done, but don't mind the complexity of what you see. It is very simple to understand it by putting a paper beside you and trying to do what I have done. Now, don't mind this, but pay attention to how it is being used. If you are given a problem involving the regression of y on x, you would have to determine your a and b values. For you to obtain your a and b values, you can use equation 1 to obtain a and equation 2 to obtain b. But the thing is this, I started with saying that this equation equation 1, which has a expressed in this form, can be modified to get something even simpler that can help you solve the problem faster. And that is where I started with saying simplified for a. That is simplification for a. How would you simplify a? I said to simplify a starts with bringing what a is down here. So that's where I started with. I brought what a is. I now did my expansion. I ignored the sigma, this summation operator. I ignored it and then did my expansion. My expansion required me to multiply. So this is what I did. For those of you just coming, this times this will give me xi times yi will give me xiyi. That's how I got this. Xi will now multiply y bar. It will give me xi y bar. After using this first term to multiply the two terms in the other bracket, you now start with this other one. Minus x bar times yi will give you minus x bar times yi will give you minus x bar yi. And minus x bar times minus y bar will give you plus x bar y bar. So that's how I got this one in the numerator. After doing that, I now expanded this denominator. I hope you know that xi minus x bar all squared is the same thing as saying xi minus x bar times xi minus x bar. Okay, so if you expand, xi times xi will give you xi squared. Xi times x bar will give you minus xi x bar. Then using this now, minus xi times minus x bar times xi will give you minus xi times x bar also, and minus x bar times x bar will give you plus x bar squared. So if you add these two, which are like terms, you end up having xi squared minus 2 xi x bar plus x bar squared, and that's how I got this denominator by expansion. Okay, now from this denominator, the next thing I did was to open the bracket. The sigma is an operator, and it is a linear operator in particular because you can use it to open up this bracket. The sigma, when it opens up the bracket, it will take each term one after the other, and you must note something. Whenever the sigma takes each term, it goes after the variable and ignores the constant. Not that it ignores the constant, it brings the constant out. So when you take summation of xi yi, it will not ignore xi, it will not ignore yi. Why? Both of them are variables. But when it goes to the next term, in the next term you will notice that you have minus y bar, which is a constant. A constant will come out from the sigma, and the sigma will operate on the variable, which is xi. Now if you go to the next term, the sigma goes to the next term, it will bring out x bar. Why is x bar a constant? Why is y bar a constant? Y bar and x bar represent the means. So x bar is the mean of x, all x values, and y bar is the mean of all y values. So sigma would usually bring out constants, going after the variable, bringing out constants. So it brings out y bar because it is a constant and goes after xi. It brings out x bar from the third term because it is a constant and goes after yi. But here, you don't need to bring out because you may not understand easily. So I'm just leaving this, although both of them are constants. The product of the two of them. Welcome, Ayan. Welcome. So both of them are constants. X bar times y bar will give you a constant. Now I came to the denominator, in which case I have this. The sigma opens this, and this. It opens this bracket taking this, and this. When it takes this is a variable. So the variable squared remains a variable here. When it takes the second term, 2 is a constant. It brings it out. It takes x bar out because it's a constant but concentrates on xi. When it comes to the last term, this is summation x bar squared, which is a constant. Now from here, I now went on to get the next step, this step. Now in this step, what did we do? I had to simplify further. Now the mean of all xi's is represented as summation from I equals 1 to n xi all over n. If you make summation from I equals 1 to n of all xi's your subject of formula, your result will be n times x bar. Now it means I can write, wherever I see summation, I can write the result as n x bar. So in place of this, I brought n x bar. Now the same thing applies to y, summation yi. Anywhere you see summation yi, you end up putting ny bar. So I replace that with ny bar, which comes from here. Okay, because y bar is the summation of all yi's all over n. So if you make summation of all yi's the subject of formula, it will give you n times y bar. So anywhere we find summation of all yi's, what do we put? We end up putting ny bar, and that's what I did here. So this will now be the summation of x bar, y bar. Now when you sum a constant n times, if you sum 3, add 3 to itself 3 times, what is your result? 9. Getting 9 means multiplying 3 by itself 3 times. Okay, multiplying 3 by 3. So why are we using this 3 to multiply 3? It's because 3 added itself 3 times. Okay, so when you add a constant n times, x bar and y bar are constants. So the product of two constants will give a constant. When you sum that constant n times, it will give you n times that constant. So that was how we settled the numerator. Coming to the denominator, summation of xi squared remains because it is not a constant. But over here, minus 2x bar times nx bar. Why are we having nx bar? It is because there is a summation xi here, and we are replacing summation xi with nx bar. So if you replace that, you get this result. Then this is summing a constant x bar squared n times. It will give you nx bar squared, and that's how we got this result. Then we now move to the next line. From this, we got this. What did we do in this step? We had to rearrange our result for it to look more organized, more beautiful, more elegant. So we now did this. So minus y bar times n times x bar was rearranged to give n x bar y bar, and minus this was expressed as n x bar y bar plus n x bar y bar. Now you notice that n x bar y bar minus n x bar y bar will give 0, so we are left with this result which comes down here. Now if you go to the denominator, this is just like saying, you will notice that this and these are like terms, and this is common. This is just like saying 2a minus 2a plus a. The result will be minus a, which in this case a is nx bar squared, and that's how we got this result. So we now simplified further. What did we do finally? We brought in what x bar is. What did we define x bar to be? We defined x bar, the mean, to be summation xi all over n. So we brought summation xi all over n to represent x bar, and we brought summation yi all over n to represent y bar. Now, one of these n, there are two n's here, this and this. One of the n's will be cancelled by this n, and you'll be left with just one n. And if you do that for the denominator rather, x bar squared means putting what x bar is and squaring it, and that's what we did here. What is x bar? It is summation xi all over n. So squaring it gives this result. Now, I now brought us to this, the next step. In the next step, from the last result, we now had to do this. We had to simplify. So that n had cancelled that n, leaving us with the product of these two all over n. And in the numerator, this all over this all squared means the numerator squared all over n squared. And when n cancels n squared, you will be left with 1n. And that's how we got this result. Finally, because we cannot leave our result in this manner, we now took LCM. What is the LCM of 1 and n? This is the same thing as writing, this is the same thing as writing this all over 1. So I wrote this as this all over 1 and wrote this as this all over 1. Now, what is the LCM of 1 and n? It is n. If 1 goes into n, it will be n times. N times the numerator will give you n times that numerator here, minus, if n here goes into n, it will give you 1 time. 1 times this numerator here brings this here. And we went to the denominator. For the denominator, the LCM again is 1 and n. 1 and n, the LCM is n. Now, 1 into n will give you the numerator, will give you 1 into n will give you n. N times this numerator gives you this result. And n into n will give you 1. 1 times this numerator will give you this numerator. So we ended up having this result. I now brought up this simple rule that if you have a over b divided by c over b, the result will give you a over c. That means if you divide a by something similar to what you are dividing c with, you will get the result to be a over c. So this all over n divided by this all over n gives this final result, this as your a, and b is equal to y bar minus ax bar. Now, let me quickly tell you how this will be used. Let us see how to solve a simple problem on this. Now, let's assume there is a question in this manner. The question gives you a data set like this. Okay, let us look at a data set like this, having this as x and this as y. 1, 4, 2, 1, 3, 2, 5, 3. Okay? Let's assume this to be a data set. And the question now comes, regress y on x. Now, once the question asks that you should regress y on x, all you have to do is to know that regressing y on x will give you a result as this, ax plus b. But this is not the result they want from this question. They want you to get the value of a. You would only be able to answer this question if you know the value of a and the value of b. So once you are given a question like this, what do? You quickly come over and expand this table. Okay? So just follow what I'm doing. This will show you how simple the question is and how simple it is to do what I have done so far. Okay? So I will do this. Now, I will bring my x values, I'll bring my y values, the same way they were given to me in the table. What were they given to me as? 1, 4, 2, 1, 3, 2, 5, 3. Now, remember what we've gotten as our result. Look at our result. What do you find in your result? You find in your result A, xi times yi. Because there is xy times yi in this formula, I'm going to bring this here. I'm going to create a column for x times y. And in this formula again, notice that there is x squared, xi squared. So I'm going to bring a column for xi squared. Okay? So this will be xi, this will be yi, xi, yi. Now, once you do that, you will now start the problem in this manner. The first thing you are going to do, if you look at your B, notice that your B demands that you find the mean of y and the mean of x. So, what is the mean of y? Let us start the question with solving this. We will obtain x bar. X bar is summation xi from I equals 1 to n all over n. And in this case in particular, your n will be 1, 2, 3, 4. There are 4 values under x. It means your n will be 4. What is summation xi? Summation xi is you adding everything under xi. 1 plus 2 plus 3 plus 5. 5 plus 3 is 8. 8 plus 2 is 10. 10 plus 1 is 11. So this will be 11. And you will now end up having 11 here. Then if you go to your y bar can be obtained as summation yi all over n from I equals 1 to n. In this case, what is your n? Your n is also 4. So this will be over 4. And what would you have? 4 plus 1 plus 2 plus 3 will be your summation of all yi's. So 4 plus 1 is 5. 5 plus 2 is 7. And 7 plus 3 is 10. So that is what you would have. Okay? Now, let's proceed. So for you to get, now that you've done that, you bring your 10 here. I'm showing you how to use the formula we have just established to get the regression of y on x. Now, once you do that, once you obtain the mean, you can see that you can quickly obtain your b. But hold on a little bit. Let us now go to this column xy. How do we obtain xy, the values in this column xy? We will multiply every value of x with y. So 1 times 4 will give you 4, 2 times 1 will give you 2, 3 times 2 will give you 6, and 5 times 3 will give you 15. Now, if you add them up, 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 15 will give you 27. So this will be 27, the total. Now, you would come over to this one, xi squared. What is xi squared? Xi squared is you squaring every value you see under xi. 1 squared is 1, 1 times 1. 2 squared is 2 times 2, which gives 4. 3 squared is 3 times 3, which gives 9. And 5 squared is 5 times 5, which gives 25. Now, if you sum this up, you end up having 25 plus 1, 26. 26 plus 9 is 35. And 35 plus 4 is 39. And that will give you your total. So once you get this total, you will now come over and bring them into this formula. Okay, so let me bring the formula a little bit downward. So what do you have here? In the formula for A, you have n, whatsoever n is, times the product of the summation of the product of xi, yi. What did we get xi, yi to be? 27. So I'm going to write here A equals n, which is 4. 4 times the product, the sum of all products of xi, yi, which is 27. So this will be 4 times 27 minus, I'm going to come over here, the sum of all xi's, which is 11, times the sum of all yi's, which is 10. I'll bring that here. All over the sum of all xi squared. What is the xi squared? 39. So this will be n 4 times 39. Okay? Minus the sum of all xi squared. So this will be 11, the sum of all xi all squared. And you can now use this to obtain your result. So 4 times 27 will give you 108 minus 11 times 10 will give you 110. Okay? Then all over 4 times 39 will give you 156 minus 11 square will give you 121. Now, What is 108 minus 110? 108 minus 110 will give you minus 2. And what is 156 minus 121? 156 minus 121 will give you 35. What is minus 2 divided by 35? Now that you've gotten A to be minus 2 over 35, you will now come over to your B. What is your B? For you to obtain your B, all you would have to do will be to recall what B is. What is B? B is y bar minus ax bar. Okay, so B now will be equal to, what did you get your y bar to be? Remember, we got y bar to be 10 over 4. So you will bring y bar 10 over 4 minus A. What is our A? Minus 2 over 35. What is your x? What did we get x bar to be? We got to be 11 over 4. So you bring in here 11 over 4 and then simplify. Okay, when you simplify, what would you get? You have 10 over 4 plus, minus times minus is plus, 2 times 11 is 22. You end up having 22 all over 35 times 4. 35 times 4 will give you, 140. Okay? And the LCM of 140 is what? The LCM of 140 is 140 because 4 is a factor of 140. So 104 into 140 will give you 35. 35 times 10 will give you 350. Okay? Now 140 into 140 is 1 times 22 is 22. And this will give you 372 all over 140. Now, once you get your value of B and you've already gotten your value of A, your regression equation can now be written. So what would your regression equation be? You write out the values of A. Let me write it out again. A was gotten to be minus 2 over 35 and B was gotten to be 372 over 140. So what did we say our regression equation looks like? We said it looks like this. Regressing y on x is you writing y equals ax plus b. So now that you know the value of A and B, you can now regress y on x. And your result will be minus 2 over 35x plus 372 over 140. And this will be the regression of y on x. Thank you very much for watching this video. Please smash a like on the video. Go over this video again and endeavor to share this video with your colleagues. Let them watch this video from the beginning to the end, patiently, painstakingly, and they would understand everything that was done, step by step. What have we been able to achieve in today's class? We've been able to establish a formula for A and B, the parameters of what is called a regression model. Okay? And with this regression model, yes, Uforo, I'm listening. If you have a question, please ask your question before I round up the video. Okay? Now, please watch the video all over again, step by step, to understand what was done. Okay? If you watch it all over again, put a paper beside you, take it step by step what I have explained, and you will understand it. It is very, very simple. In this video, we've been able to regress y on x. My next video, which may be my final video or the second to the last video on this particular topic, will be, okay, Uforo, thank you very much. Please don't just be wild. I want you to watch the video and understand. I'm after your understanding. I'm after knowledge. So what I would want you to do, guys, is to watch this video, share it with your colleagues from other departments, share it with them, and make them watch the video with you. Try to ask questions. Please feel free, send in your comments. I really appreciate your comments. Please, everybody, smash a like on this video, and I'll be seeing you shortly in the mathematics class, where we shall be looking at quadratic equations. Thank you very much. I won't say good night because I'm expecting you in the next class on quadratic equations. Thank you.